and back to the tutorial for deep learning. Today we're going to discuss the basics of semantic segmentation. Here, one tag for this business summit and just use for reference here. So before going to semantic segmentation, we have to know about what is segmentation. That is image segmentation. We can say so one of the process or task that help you to divide the image into subparts or some other parts like that. Suppose if a object we can divide into, if suppose an image, there will be a considered 5 objects. We can divide the object like that, objects 1, object 2, and so on. And there will be a key task in this computer vision and image processing is segmentation only. So how can you perform this segmentation? So if you want to perform the segmentation, we are now the types of segmentation to here. That is semantic, instance, another one is the panoptic like that. So most of them consider about the semantic only. So this is an example screen given about image segmentation as well as the and show the difference with the object direction. So image segmentation, what are the image you want to divide subparts, and the object direction we have to deduct what are the objects, how many objects. Suppose the screen you have 4 objects, you deduct the objects 1, 2, 3 like that. Then where we can apply this segmentation. So these segmentations where we can apply in the smart agriculture, image editing, medical image and diagnosis and dataset augmentation also here. Let's go for the definition of what is instance segmentation and semantic and phonetic segmentation. Semantic segmentation is the first type of segmentation where it helpful to visualize or produce a contextual description of the stuff in the image. Here, classes may have visualized but not objects here within the same class like that. Then instance segmentation case, this producer. So this is a semantic segmentation example where you can see the objects are here like that, 1, 2, 3 like that. And then instance segmentation where we are going to find out, because here it will always give the better description that also list objects as well as individual instance of the thing. So here how many individuals, 1, 2, 3 individually, it will give the box and everything and show you differences. Then panoptic segmentation, these combine the feature of both semantic and the instant here. This helpful to now the environmental context. Here say like this 1, 2, 3 like that. Generally we are following semantic or else instance segmentation only. Here this is the image segmentation using deep learning. So if you follow this concept, we have to remember the two things called, one is called deconstruction, another reconstruction. The deconstruction done with the help of the process called speech extraction, where you have backbone, encoder is there. And reconstruction we have upsampler, where following the decoder here. So this is the diagram. Suppose you want to train take the images data set and want to train. So let's assume that there will be cat. After prediction and training, it you have to say everything. That means the object like the sky, tree, okay, and the cat and the grass also. So it you have to find out everything here. Then deep learning segmentation, the basic thing is unit architecture. So it follow ensure the encoder and follow the decoder here. So in the previous session, I explained already what is unit architecture and so on. So later I can go through it. If I have any comments, you can comment the box also. So generally in unit, what happens, there will be encoder and decoder is there. Whatever the input is there, it will pass to the encoder. Then the encoder extract the hierarchical features with downsampling operation. Then decoder is there. Decoder perform the downsampling operations. At last, it produces a segmented map here. This is helpful to predict the output, visualize the output also. That is segmented output we can see here. Along with the convolution, Maxwell layer as well. Sorry. So this is the semantic segmentation output. So if you want to perform the segmentation output, we can follow the technique like one-part coding, or you can say class with the highest score also, we can set it here. Then additionally, if you want to know about the instance segmentation, where you can follow boxes, just as I told you, these are post-processed or recolor mask in order to distinguish the instances. So like this, and these are some information. And instance segmentation, just I told you, extension of direction models where you can say instead of predict boxes, where the model put mask also. See here, this is the input image where after training it follows the ROA concept. That is ROA concept is there. Then follow the class box with the help of convolution operations. At last predict the object exactly and box it also. Instantly doing here. Then panoptic, this is a combination of both where let's assume the input image where follow the dilated FCN and mask RCN and instant segmentation, semantic perform. At last, it gives the clarity that gives perform the operations, give the parametric segmentation here. So quick and good. So if you come to parametric, quick and good, later you can, if you have time, you can go for implementation through the Python here like that. And data types. What kind of data types you can follow here? You can follow either the object or label mask or a very high annotation effort also. Then accuracy matrix. So if you come to this kind of segmentation, image segmentation, we have to consider about this one ground truth and predicted pixel, where you have to know about the IOU, that is intersection of union. Then computers, if you want to perform this deep learning with image segmentation like semantic anything, we need support of a same backbone and segmented head and post processing demands also and additional overhead also. So these are the information about the segmentation. What is segmentation and what are the types of segmentation and why we need segmentation and what practical exams you can or what kind of things you can do with the segmentation. Thank you for watching the video. Thank you.